Welcome to the presentation of learning control Lyapunov and control barrier functions through neural networks. I'm Yue Meng from Aeroastro department. Control Lyapunov function and control barrier functions are certificates for systems stability or safety. However, for complex nonlinear systems, they are hard to construct. In this work, we propose a data-driven approach to construct those certificates and also the controllers using neural networks. A control Lyapunov function V should be positive for all non-zero states and should be zero at the origin. Also, there should exist a controller that makes the time derivative of V decrease for all non-zero states. To achieve this, we parameterize the CLF and controller as two neural networks and collect samples from simulation. We enforce those constraints by optimizing via the loss function defined here. In this way, the neural network acts like a CLF and can guide the NN controller to enforce stability property. Similarly, for control barrier functions, we can also represent the certificate and the controller as neural networks and use the loss function LCBF to satisfy the related constraints. We first test our CLF-guided controller for the inverted pendulum experiment. The goal here is to keep the pendulum in the upright position. We first train the CLF via a pre-trained RL controller, and then fix the CLF part and train a controller to satisfy the Lyapunov conditions. As shown from the animations, our learned controller can drive the pendulum to the upright direction for all possible initial condition settings. Next, we test for our CBF-guided controller on a highway driving dataset. The goal here is to do safe multi-agent planning. We measure the safety by the collision rates and compare with many baseline approaches, including adversarial imitation learning, behavior cloning, and model predictive control. Our approach achieves the lowest collision rate. In this project, we successfully used neural networks to construct CLF and CBF to enforce system stability and safety. For future works, we would like to learn other certificates such as contraction metric. Thanks for watching.